Alright, welcome to today's Circuit Playground Express tutorial. Today we're talking about how to use sensors a little bit more. Last time we talked about how to make an automatic flashlight. Basically, the darker it is, the brighter it gets. Put a flashlight on it to turn off the lights entirely. Today we're going to be talking about a different sensor called an accelerometer. Now, if you know anything about physics or you've taken a physics class, then hopefully you already know what acceleration is. But in case you haven't, acceleration is basically how quickly you are changing speed. So in a car, for example, you accelerate when you press on the gas pedal because you are getting faster over time. Right, so acceleration is just the change in your, technically velocity, but it's the change in your speed. And this board is able to detect that. So in the center of your board, you will see X, Y, and Z, kind of this little, these three little lines, or sorry, two lines and a circle. So X and Y are the lines, and Z is the circle. So the way you can think about this is it's showing us the three different dimensions and which direction those are in. So if I go like this with my hand, right, my thumb is my Z direction, right? It's going in and out of the board. And then I have my X direction is my finger, which goes going in the way I have this oriented right now, kind of up and down. And my Y is my side to side. So basically, if I were to move my board up and down this way, then that is along the Z direction. Side to side this way is my X direction, and side to side this way is my Y direction. So use those markings on the board to help you figure out where exactly each direction is, and kind of familiarize yourself with that because it's going to be important as we move forward. So our goal today is to basically make something where as we tilt the board, the light is going to kind of circle around, right? So you can think about it as kind of like dripping down. So if I hold the board like, let's see if I can get this here. Right, if I tilt the board like this, then I would want the lights to kind of like flow down towards this end of the board. And if I tilt it back, then I would want them to kind of flow down towards this end of the board. Or if I tilt it this way, then I would want them to flow down this side. And if I tilt it this way, I want them to flow down to that side. Sorry, it's a little tough with the camera angle. Hopefully you are understanding what I am meaning. And with that, let's head over to our code. As usual, if you're working from the code that we have from last time, we're going to block out this section in a comment. So I'm going to take this, which is the top of my comment block from the last couple of tutorials, and move it up. So this way, I still can see all of that work I've done. If I need to remember how to do an if or an else statement or a for loop or whatever, it is still there for me to look at. You can also delete it, but if you get stuck, it's really nice to have an example just below. The first thing we need to do, this is going to be really similar to our last tutorial on how to use the light sensor. The first thing we're going to want to do is figure out how do we take a look at what the accelerometer, that sensor on our board, is even seeing. And the way we're going to do that is just like before. And again, this is why we're going to leave that older stuff, because I can say, hey, look, I use this print statement so I could look at what the light sensor is doing. I'm going to do something similar here. So I'm going to print. Again, I want something from the board, so I'm going to do CPX. And then I've always said, we want computer science to be obvious and make sense. So if the light sensor was CPX.light, then the accelerometer should be CPX. Something to do with acceleration, and it is CPX.acceleration. All right, so this is our step one. And I'm going to open up my serial monitor, because if I don't do that, I'm not going to see what my code is doing. It is still currently running my automatic flashlight code. I need to save it in order to make the new code run. So what I can see here is that when I do this, I have an acceleration of -1 in the X direction, -0.22 something in the Y direction, and about 9.5 in the Z direction. So some of you might be like, okay, well, first of all, why are these not all 0? Like, the board's not moving right now. And that's because of a couple of different things. So the first and one of the most important things to understand is that there is always acceleration from gravity while we are on Earth. So if we look right here at the z direction, that is about 9.5. Generally, we say that, well, this is in meters per second, which is like a standard unit for acceleration, or sorry, meters per second squared, which is a standard unit for acceleration. And the acceleration of gravity is about 9.8 meters per second squared. So basically, this is getting the acceleration of gravity. This should make sense because remember, our z direction is like into the board, up and down, right? So I showed you is kind of like, whoop, so it's my thumb coming out. So right now, this is being pulled down, and so my z direction is going to be about 9.8. And then if we actually, let's go back and look at my board again. You maybe can't see it here, but there is a little bit of tilt. Like I can kind of stick something under the back of this board. And so my z is a little bit less than 9.8, and my x is a little bit off of 0, because when we tilt and move things, then that 9.8 kind of gets spread around the different directions, is the way you can think about it. If you've done physics, then you know I'm kind of fudging a couple things, but hopefully this gets the idea across. The other thing is that just like with our light sensor, we are going to have calibration stuff going on. So basically, it might not be perfectly calibrated so that 0 is 0. So we might see some kind of small numbers that are off. But generally, we're not looking to find out we're not testing what exactly is the acceleration of gravity on Earth in this particular spot where I am. We're looking at how these accelerations change relative to each other in order to see, to make our lights kind of move around the board in response to that. So we're not super concerned if this isn't exactly 9.8, if it's totally flat. And also, depending on where exactly you are, there might be a slight difference in what that number looks like, because really it's kind of an approximation. So don't worry too much about the exact numbers. Just know that it should be, if it is facing so that gravity pulls it down, you're going to see a number that's around 9 point something. If your board is calibrated slightly different than mine, you might see like 8.9 or 9.7 or 9, something a little bit higher. That is okay. Don't stress out if that happens, because again, we are going to end up just kind of comparing X, Y, and Z to make our code run. All right, so we have this print statement, and just like before, how many times is it running? Once, because our code's only running once. And so I can run it and I can look at like, okay, if I move the board a little bit and then I press save, right, I'm going to get some different numbers. So I moved this so that the X direction is down, so now it's about 9.3 in that direction. Cool. But just like before, it's kind of annoying when we only have one reading. And so what are we going to do in order to make this do multiple readings? A loop, right? We want the code to repeat. So I'm going to do a while true loop again. Again, you can use a for loop if you want it to run a certain number of times. Make sure you tab in the stuff you want to be inside of your loop and repeating. And don't forget your time.sleep so that your board doesn't overload and so that you can read it. And then we'll press save. And now I can see, whoa, all these numbers. And I want to move my board around and be like, okay, cool, that makes sense now. X is about -9. If I flip it 180 degrees, then X should be about positive 9.8. I should be able to do the same thing with Y, and then flip my board totally over. I can see Z's around. It's really hard to get it perfectly even. So you should just kind of get a feel for how these numbers are changing. So now it's back flat on my table, or flat-ish on my table. Okay, so now the question is, we have all of this data. How do we make it, and how do we use this data? So before in our light sensor, we only had one piece of data we were looking at, right? It put out a number like 54, 65, 3. In this case, we have 3 different numbers. And like I said, we're going to be comparing those to one another to make this work. So if we want our board and our program to make decisions, does anybody remember what we do? If and else. Right? So, make sure you know that. Anytime you want your board to make a decision, anytime you're looking at data, remember that you're going to use if and else. But before we get there, let's talk about what exactly we want our board to do. Because just like before, if we go into this without a plan, it's going to get really messy really quickly. So now we know how to use this acceleration thing. We can see our numbers. Hopefully you have a good understanding of what exactly it's reading. But let's talk about what our code is actually going to do. So go back over here and get our pen and paper out so we can think a little bit and have a record of what we are planning to do. So my thought is that what we can do is we can use this as our reference. So if the board is tilted this way, then I want my lights on this side. So I'm kind of going to do a little drawing. So I'll say, like, if my board looks like this, then I want my lights down here, right? And then if I tilt my board the other way, I want my lights down here. I'm going to start really simple like that. Eventually, if you want, you can get it so that you can rotate the board in all 3 dimensions and have it go. That does get a little bit more challenging though, so we are going to keep it simple for right now. And this is just rotating it on one axis, so it's not too bad. Okay. And let's see. One of the first things I'm going to need to do is figure out which lights are which. So I'm going to go over to my code, and I don't remember off the top of my head, but I'm guessing, let's try. I know that on the opposite sides, one is going to be 0 and one is going to be 9, right? Because those are the highest and the lowest. So let's figure out which side those are on. So I'm going to go over to my code, and what I'm going to do is I'm just going to turn on those 2 pixels. So 0. And then I'm going to just copy and paste this and then change the number. You want to be careful with copying and pasting. But for something like that, I think it's fine. So I'm going to run this. This should turn on 2 lights red. There we go. Okay, so that is this side. So I'm going to write down on my piece of paper. Okay, so if I'm tilting it this way, then I want it to be 0 and 9 that I'm turning on, which means that 0, 1, 2, 3, 4, and 5 are the ones I'm turning on for my other side. And now comes the part where we have to figure out how to calibrate our board. So we know that if the board is like this, we're going to have about 0 for X and Y and about 9.8 for Z. But if I'm tilting it this way, right, the way where I want the lights to kind of flow, right now, if I look back at my scrolling numbers, Y is high, right? So I would say it's like above 8 seems reasonable when it's kind of tilted pretty far. So I'll go back over here, so I'm kind of holding it like this, right? So on my paper, I am going to write down that when I am tilting it towards 0 and 9, then my Y value is greater than 8. Whoops, there we go. Y value is greater than 8. And let's see, if I tilt it the other way, right, for my second set of conditions, I'll look back at my code, and I'll see that, Y is also, oh, you know what I missed? This has a negative. So we'll say, let me go back over here. So now I'm tilting it this way, and I'm noticing, I missed this on the first try, that Y is negative 8. So I'm going to make sure I put that in here, that Y is not greater than 8, but Y is less than negative 8, right? Because negative 9 is less than negative 8. And if I tilt it the other way, then I see that Y is greater than 8-ish. Yeah. You can do greater than 7 if you want. Remember, this is all about calibration. So this calibration is something that you decide. This is your code. I am doing greater than 8. If you want to do greater than 7, if you want to do something else entirely, you are welcome to do that. So, again, this is an example of thinking things out, writing them down, so that you don't run into problems later on. Okay? So, what I'm going to do is go back to my code and use this as a reference to create my if and else statements. So I'm going to come over here, and I'm going to say if. Oh, you know what I forgot to do? I forgot to make those variables. So right now, do we see how we have X, Y, and Z? We need to actually get those. Right now we're just printing them out. We need to save them as variables so that we can access them to use in our if and else statements. So what I'm going to do is I'm going to say x comma y comma z equals CPX dot acceleration. So I am creating the variables x, y, and z. And I'm saying that they are equal to x, y, and z. And to prove that this is working, we are going to print x and make sure that it looks like the x that the other print is giving us, just to make sure we're doing everything right. Okay, yep, those look like they are matching, so that does seem like it is working. So I'm going to get rid of that print because I don't need more prints to confuse me. So now we have x, y, and z. And if we look back at our notes, the one we care about is y. And we want to say, if y is less than -8, then we want to turn on 0 and 9, right? So we're following along of this set of kind of conditions, this scenario right here, and changing it into an if-else statement in our code. So I'll say, if y is less than -8, then I want to turn on these two lights. Okay? And then I'll say, elif, right, y is greater than 8, then what do I want to do? I want to turn on, so I'm doing my second scenario now, right? So if y is greater than 8, then I want to turn on 4 and 5. So I'm going to come over here. I'm going to copy these. I'm going to paste them. And I want it to turn on 4 and 5 and make them be red. Now, what we're going to see happen is that if we do this way, well, actually, I'll show you. I'll do an else statement because you always want to have an else statement. This should be like a sandwich, if, else, and then a bunch of elif in between. So the bread is your if and else. In this last one, I'm just going to turn all the pixels off because if neither of those things is true, then I don't want any lights on. All right, so this is our code for today. Let's see how it does. So right now, my board is flat on the table and my lights are off. That makes sense. We can look at our code and see that y is very small. Cool. If I start to tilt it this way, whee, we can see that as I tilt it more, then my lights start to turn on. And you might say, well, okay, this isn't, I don't want it to have to tilt that much. Cool. Change your calibration. Look at your y, figure out where you want it to turn on, and then we'll tilt it the other way and see that those lights start to turn on. So we're starting to kind of get the hang of this. And that looks pretty good to me. Yeah, I think that looks pretty nice. Let's go to our next challenge. And that is try to make the x direction tilt work. Right, so if it's tilting this way and tilting this way. So now you have kind of a model for how this should work in your code. Try adding to it. See if you can make it do both the x and the y thing at the same time. If you are feeling really adventurous, you can try to make it actually flow, right? So as you tilt it, like I said, as you kind of tilt it around like this, you can make it flow. Another way that's a little bit easier to do it is to just do it in one direction. So rather than doing a full, working with all three things, if you pretend in my video that like, that direction is down, right, then the gravity would be pulling from here, and you can do it kind of like just rotating. And that can let you do some cool stuff. But try adding to this code. See if you can get it to do some interesting things based on the model that I've given you. And the thing that I was going to share that actually didn't happen, and I'll explain why it didn't happen, the thing that I was going to add into my code was something to turn off the lights when something to turn off the lights, so that you don't end up with both 0 and 9 and 4 and 5 on at the same time. This didn't end up being an issue because in order to get to these two conditions, you have to go through a space where you're using your else, right? Because y can't jump directly from -8 to +8. Unless you put like a really big time dot sleep. But you may end up, depending on which of these things that you're trying, having some issues where like lights aren't turning off the way that you expect them to. So if you have that happening, find a good place to turn off all your lights. You might do it every cycle at the start of while true loop. You might turn off certain lights at certain times within your if and else statements. But be prepared for some lights that aren't turning off the way you want them to as you get more complicated in this. So go ahead and try something, and I'm going to show you what I feel like trying in just a minute. All right, so if you're back, we are going to look at how to add in that X and Y tilt. Actually, you know what? Why don't we do... Yeah, we'll do the X and Y tilt added on top of this. So let's see. We have our if and our elif for y. You can add another if and elif for your x, right? You can do it in a whole nother thing here. And the advantage of that would be, and I'm going to be super lazy here. You want to be very careful with copying and pasting. But what I'm going to do is do it in a separate one and show you how that lets you do something pretty cool. So first off, I'm going to check which direction is which, just like before. So I'll turn this on. See, I'm tilted this way. And my x is positive. I'm tilting this way. And my x is negative. Okay, so if it is tilted towards the positive direction, then I remember that this one is 0 right here. So that would mean I would want to turn on what, like 2, 3, or 1, 2, and 3? I'll turn on 1, 2, and 3. It'll just make it look nice. So I'll do 1. Oh wait, was that the positive and negative direction? Okay, we gotta check this out. See, this is why it's good to write things down. Otherwise, you end up like this. So my x is positive. Okay, so I want to do this to actually the other one, to this one right here. So I want to turn on 1, 2, and then 3. And instead of bread, let's make those green. I'll have a little bit of a different color. Mix it up. And these ones will be green too. And when y is negative, then we're going to want to, let's see. Let's look over here. Y is negative, so this one's 9, so it'll be 8, 7, 6 that we want to turn on. Go back to our code. Whoop. 8, 7, and 6. Okay, cool. So the one thing that's going to get interesting with this is that we have the cpx.pixels.fill off in the else statement for both of these. So we'll see what happens with this. I may end up combining these into one thing. All right, so it's flat. Nothing should be happening. I should tilt it this way. My green lights come on. And I'll tilt it this way. And my other side, you can't really see it. I'm trying to show you. Yep, there we go. And then we tilt it this way. And my red lights should turn on. Right, okay, here. So now we're getting some interesting flashing. I'll explain why that's happening, but it is still working. So the reason we're getting some flashing is because if you go back to our code, remember that we have if and elif. So if we have two sets of if, it's going to check both of these things independently. So it's going to check this, and it's going to say, okay, hey, I want to turn these on red. And then it'll go through here, and if it goes to else here, it's going to turn all the pixels off. So that's where we're getting our flashing from. The reason that we don't see flashing on the green is because it's already after this bit of code is run, so there's nothing to turn it off and make that flashing happen once it has already turned on. Because our time.sleep is up here. Okay? So we could move that, and that might have an effect on it. We could put these all into one giant if and elif set of statements to deal with that. Let's try that. Let's see what that does. So remember that order matters. What this change is going to do is it's going to make it so that if y is less than 8 will be checked first. If y is greater than 8 will be checked second. So our pixels will only start to turn green if the y's are not within that range. Okay? These will have priority because it's going to run in order. So let's see what this looks like. So I'll tilt it this way, and I should get my y, no flashing this time. I'll get my y this direction. I'll get my x this direction. Yeah, I can see it kind of reflecting hopefully a little bit, and my x this direction. Cool. So this kind of works, but the thing is, if I tilt it in like a sideways direction, I am going, oh sorry, I chose the bad direction to do that. Whoop. Okay, let's see if I can get it. It's always going to default to the red. Like I'm not going to be able to get both the green and the red at the same time, which you may have seen briefly did happen when I had my code the other way. So there are pros and cons to doing however you want to code this. But I'm going to show you one more thing before I let you go for today. I know this is probably a longer one. And that is how to add in and into your if statements. So, for example, right now I have if y is less than 8, if y is greater than 8. But what if I want to do something special if y is less than 8 and x is less than 8? Or maybe not 8, but we'll walk through that in a minute. If we want to check both x and y at the same time and get one of those kind of diagonal angles and turn on lights specifically for that case. So the first thing we want to do is go and we want to tilt our board. Whoops, so let's say this is the angle we're trying to get. And so if I go back over here, I can see that my x is less than -6 and so is my y. All right, so let's kind of go back over, draw this out. So if we have this like kind of funky angle, so my board is kind of like mostly tilted this way, but kind of tilted that way, so it is tilted, let's show that. So this is my plug coming out of my board is on here, and so it is tilted kind of down this way towards gravity, right? So my x is less than -6, and so is my y. And in that case, I'm going to want to turn on, let's turn on like all 3 of these lights. So 0, 9, 8. We'll turn on 0, 9, 8. Those are all the kind of lights that are in that direction. Sorry, I was writing off screen. Cool. So what we would do is go back to our code, use that as our guideline, and say we want to put this first. If we don't put it first, then anytime x is, well actually, it might work to put later on. Let's try putting it later on. Let's mix it in after our y's. Let's see what happens with that. So we'll say if y is less than -6, and you literally just write the word and, x is less than -6, then we want to turn on 3 pixels, and I'm copying that again just so I can be lazy. I'll say 9, 8, and 0. That's going to bother me. Okay, 0, 8, and 9. Right, and let's make them blue just so it's super clear that we're doing something different here when we look at our board. All right. So we're going to come over here. We should see green. We should see green. Make sure everything else we had before still works. Red, maybe? Yeah, I can see it. Red, red. Now let's see if we can get that angle on it that will make it go blue. There we go. So now I can get kind of that blue. Hopefully you can see how you can use this to help you make the board go around. And have it hit like all of those things as you twist the board. So right now it's a little hard. My Y up there is a little bit high to really get, unless I'm like really twisting it down. But play with that. See if you can get it to rotate around the entire board if you haven't already. And hopefully you are starting to feel a little bit more comfortable with all of this. But yeah, accelerometers are fun. They let us do some pretty cool stuff. Thanks for watching, and I'll see you soon. Bye.